So what we're going to get into now is we're going to actually get into Docker networking, Docker Compose, things like that. And what Docker Compose is a different file format called a YAML. It uses a, well, let me start this way. In this directory, we have a Python application, a Docker Compose configuration, a Docker file configuration, and a requirements.txt file. Let's start with the Docker, let's start with the app.py. And this is not going to be a tutorial about Python programming. All I'm going to say is that what this does is it goes out, it connects to Redis, and what it'll do is it'll increment the Redis cache every time you hit the page and then return that value. Okay? And then you have to hit the root of the web application here. And then, of course, this is the function that's connected to that. This is not about programming in Flask, so I'm not going to cover this too much, but this is to understand this is just the default Redis port. The host name is what's important here. We're going to be connecting to a Redis container on a private network called Redis. Okay, is that clear? So let's talk about how we do that. And we do that with the Docker Compose. This is a pretty straightforward one. It's version 3, and I think the current highest version is like 3.7, so you can do all of that. What we're talking about here is we start at the first top with the version, and then the top level object is the services list. In the services list, we're going to define a web and a Redis service. You notice the image for Redis is just Redis Alpine. Okay, Alpine is remember this is a tag, and Alpine is the smallest distribution. It's the one with the least amount of overhead. And then for web, we're going to build the current directory. This is special, and I'll show you what that does. And then we're going to expose port 5000 to 5000. Okay? So that application is going to be running in this web container, and a standard version of Redis off the shelf, the latest version, will be running in this Redis container. And they will be able to talk to each other. And they will know each other by these names, web and Redis. See where that's defined there? Now, if you go back to the app, you'll see that we actually do refer to the Redis port as Redis. Now, this is the one that's going to actually run the Flask web server and reply to the responses. So, all right, now, you notice we have a Docker file. In the Docker Compose, you notice we have a build, and then we use a dot, and that just means the current directory. So that means look for the Docker file in the current directory. Now, this could be a subdirectory, so you could easily put a path in here. I don't know, like, oh, this is less. Hold on a second. So you could easily go to the build line and say something like that, if you wanted to, or something like that. For our purposes, for this particular build, we're going to be using just a dot. So the version number is the version of the YAML. Services is the top level object, and these services are going to be running web and Redis. Now you're going to notice that when we run these, it's going to create it's going to do a couple things. It's going to create a private network, that only these two containers can talk to, and it does that. It names that network compose test underscore default, and the reason why it uses compose test is that's the name of the directory that this project is in. It does that by default. All right, let's look at what we're going to do with the Docker file. This is kind of cool. So we're going to use, again, an Alpine distribution of Python 3.7. We're going to set the working directory to /code, which is where this particular container sets its default. Then we're going to set the app name to app.py. This is an environment variable that's going to be preset and can be overridden at runtime, but for now we'll just set it up inside the build's instructions. Then you'll see that the Flask run host, this environment variable, which determines what IP address to connect to, is this one. And by default, Flask runs on port 5000, so you don't have to define that. And then we're going to run, and remember, Alpine uses a different package manager. We talked about this in the previous video, where you have to use the specific commands to the distribution you're using. All right, so Alpine uses APAC or APK, and then we're going to add, without from the cache, these packages at GCC, this one, and the Linux headers. Then we're going to copy a local file called requirements text to code requirements text, and then we're going to run a pip install of the requirements.txt file. I'll show you that file in a minute. Okay, and then we're going to copy everything into the current directory to the current directory in the current directory into the current directory of the container. And then I mentioned that by default, containers don't do anything. They just exist. They're a container. They're a preformed definition of what what the environment looks like. We're going to tell it we're going to run. We want to run the Flask command, and we're going to give it run. And then Flask knows to look in these environment variables for configuration. So this build will run, and then I wanted to mention that we want to look at the requirements.txt file. Notice, let me refresh this, that we have two requirements, and these are packages that end up installed from the pip file, Flask and Redis, okay, from the pip command inside of Alpine. So Redis is the connector to the Redis, the Python 3 connector to Redis, and Flask is the actual Flask web server package that is built into Python 3. Okay, so we're going to work with a command called Docker Compose. Now, what I want to do first is create an instance of this first application. The first application container. So what we're going to do is we're going to run a build first. Now that's going to invoke this build. It won't do anything with the Redis image, but it'll invoke the build, and you'll see how that works right now. Docker build, Docker Compose build. Now, it says Redis uses an image skipping. I mentioned that it won't do anything. It's building the instance of the container we're calling web, and it's going to do a 9-step process. The first process is pulling that Alpine thing, and that's all of the data pulling. Then we end up with this layer that is tagged with this hash, changes to this work directory, creates a new layer with this hash, removes that intermediate container, and creates a new container called that, which it then starts. Now, what you're going to notice is there's quite a few layers in this particular container. And there's 9, and just about one for one, every command in your Docker file is going to create a new overlay file system for your end container. And remember what I said earlier, you notice it's using intermediate containers, and we'll get into that. But this is actually going through and installing all the packages required to run the application. So now we're done building it. So we've tagged this compose test web. Now remember I mentioned that the container name and the networks it's going to run on is actually going to be called compose test and then the container name. So if I do, and this is going to show nothing, all right. Still nothing, right? We're going to do a Docker compose up -d. Now we've built the container. If you invoke this without doing the build first, guess what happens? It builds the containers automatically. I'm going to do it just a Docker compose up. Now what it's going to do is it creates this network, then it pulls down the Redis Alpine instance, gives you that digest, and then it grabs compose test, and you notice it creates an instance number. The instance number is how many, the number of that container. So if you had like 10 containers running, it would be Redis 10, 1 through 10. So this can be scaled, and every single one of the endpoints that it scales to will be load balanced and will all point to the same Redis container, and I can demonstrate that. Notice we got logs because we did not run the -d for detach in the Docker run command. So what we're getting, or the Docker compose command. So you're actually seeing the output from the containers, and it says it's running on port 5000. So let's take a look and see what we did. Refresh this, and every time you restart Redis, it's going to restart that value. Make sense? So right now it says it's been seen one time. So we actually have a website up that's returning. Now in this case, it can be the example website that we set up, but it could also be a web service that connects to a MySQL database or a Microsoft SQL database and does something and then returns like JSON as a return value, and that's typically how a microservice is written. It does one specific thing and then returns the call. And they don't all have to be, they're pretty much atomic. So now you're going to notice this is going to increment every time I refresh the page. So here we are creating dynamic content with a Python application and talking from one container to another, because the actual value from this, based on our code, is being pulled from the Redis cache. And no matter how many times you start that. All right, now, once we go back to this container, I'm going to just hit Control-C. And it's going to actually stop those containers. But let's say I want this to run in the background. Come on. There we go. You use the same command, Docker compose up, just add a -d to the end of it. That means detach. So what you'll get, notice that was very fast, by the way. Once a container is created and it's stopped, Docker compose, just like Docker itself, will not remove the container, it will just restart those containers. So now I have access to the command line again. Docker ps will show you the host names. Now remember, they're connected to each other on an exclusive private network called compose test _default. Now that's done by default, so you don't have to worry about that. That's always going to happen. But now we have multiple containers doing, now this could be a database container, this could be anything. So there you have it. Now, you notice that's running in the background, and indeed, if we flip over, we're going to refresh this, and it's persisted because Redis by default writes its data to the file system. All right. So it's persisting the data. Now you can also use Redis to do like session caching and things like that, or just about virtually any kind of key value store. And it's very fast at it. So it's very common to use this kind of a stack. And probably you'll notice that some PHP applications actually use Redis to accelerate their web cache. So you can store a binary object, say that's a database record set generated from a specific query, and you can store that actually in Redis. So that cache, as long as the query doesn't change, it'll be able to locate it. And that's probably a little bit beyond the scope of this, but that's what we're talking about with that. Now, how do we kill these? Now you could use your regular Docker commands to destroy these images, but you can also do now, how does it know where and what to do? Well, the Docker compose YAML is in the current directory. So if you execute this without any arguments, you're going to get one in the current directory. But let's say we're up in this directory. We're standing up a bunch of them. So I could do a Docker compose, define -f, and say, where are we at? Compose test, and then Docker compose.yml, and then say up, and guess what? It creates it knows where to find the configuration file. So the key is where the configuration file is, and that's why paths are important. Okay. Having said that, I'm going to remind you that containers are ephemeral. However, they persist on the machine they were running on until they're deleted. So if we do a Docker system purge -a, I'm sorry, it's prune, not purge. I always get those two commands confused. And you say yes. What's going to happen if we run this command again? Can anybody predict it? That's correct. It's going to repull all the images. It's going to recreate all the containers, do all of the build steps, and then stand this up. That's one of the reasons why we use Docker Compose as developers, is because Docker Compose will stand up a service for you. Now, this format is also used for other container management systems. For example, Docker Swarm, which I will demonstrate in a later video, and Kubernetes can also use Docker Compose file formats to stand up services. There are caveats with that, and we'll go over some of that when we actually approach that instruction time. So I think that's going to do it for this particular video. I just wanted to show you what the basic Docker Compose stuff did and what it kind of looked like. You know, again, this is the framework. And when I say that, I mean that this is an example of how you can do a service in a really quick manner without having to know how to install and configure Redis, and without having to install, knowing how to install and configure Flask or anything like that. You notice it's up and running. And if I hit a refresh, now what happened here? I'm going to, real quick quiz. Why did that revert to a 2? I'm going to give you the Jeopardy few seconds to answer that question. All right. The reason why, I'll give you the answer, the correct answer, is because we did a stop and a remove. Now the purge, or prune, sorry, not purge, but prune, actually removed the ephemeral file system for that particular container. So it started counting again for the Redis container. So it starts to count again. That makes sense? All right, that's it for now.